Hey everybody, so in this video I'm going to be showing you how to draw the waveform, the logic waveform, given two inputs, input A and input B. And the logic gate that we're going to be focusing on in this video is the AND gate. Now, from the previous video that I uploaded about AND gates, you'd know that the symbol of the AND gate with two inputs looks something like this. You could have multiple inputs, but in this case we're just going to be focusing on two inputs, and that's our output. So, and the corresponding truth table, let's say we have A and B as the inputs, and we're going to call the output X. Okay, so with two inputs, you're going to have four different possibilities, four different cases. Okay, and then for the AND gate, both inputs have to be 1 for it to be, the output to be a 1. So, okay, we have 1 here and the rest zeros. And the corresponding waveform. Okay, as shown here, when you just have a flat line at the bottom, that's a input of 0, and when it bumps up to this level, it's an input of 1. So you see here 0, 1, 0, 1, 0, and same thing for this one. This one, it appears to be, it starts at 1, dips down to 0, bumps up to 1, and so on and so forth. So I'm going to draw the corresponding output. So we have to keep in mind that since this is an AND gate, both inputs have to be 1 at the same time, simultaneously, for the output to be 1. Okay, so beginning right here, we just see that the A is 0 and the B is 1, but that's not enough for the output to be 1. The output has to have both inputs as 1 for the output to be 1. So beginning here, all right, we have output of 0, and then once we reach this position right here, this over here, that's when both inputs are 1, right? Up to here, because then this one drops down to 0, but the other one is 1, but we need both to be 1. So starting from here to here, we're gonna have an output of 1. Okay, and then up to here when the B drops down. Okay, and then back right here, we see B bumps up to 1, while A is still 1. That means both of them are 1 at the same time. So from here to here, okay, so from this time to this time, we're going to have an output of 1. A drops down, but B is still on. So then our output is going to drop as well, because it needs both of them to be 1. Okay, and then it's still going to be 0. And then finally, A bumps up to 1. B has been on. B has been 1 for quite a while. So that satisfies the requirement for a 1 in an AND gate. Okay, and just for that short, brief moment, we get a 1 as an output, as A is only 1 for a short amount of time, given that B has been 1 and is still 1. Alright, and then we're just going to have 0 for the rest, because A is going to be 0 for the remaining of this wave. And that's pretty much the corresponding output, given that it's an AND gate.